Alrighty, hello everybody. So today, unfortunately, I won't be in class. I will be probably in the building somewhere, just at a meeting or something like that. But unfortunately, I won't be in class today. But I do have some video notes for you guys. So let's go ahead. Let's hop right into hot number 6. So if you can go ahead and get your notes out to hot number 6, we're gonna jump right in. So today we are looking at mixture problems. Now, mixture problems. These are problems that are ones in which two different solutions are mixed together, resulting in a new final solution. So take like in chemistry, where you have to mix together certain metals or things like that. Now, today we're going to be looking at how to set up a solution table. So what this table is doing is this is just basically setting up a system of equations. These equations, we can add them together to give us a total, and that will be our final solution. So what this is saying is right here, the first column, that's used to identify the fluids or objects being mixed together. So we're going to have questions where we're mixing two different things together, and that's the name of those go here. Now the second column, the amount, that identifies the amount of each of the fluids, so each of the amount of the things that we are mixing together. And then the third column here, the value, that's used for the cost of each object or the percentage of the fluid/element. So we're going to be looking at costs for some questions, and then there will be percentages for others. And then lastly, the last column of the equation is to multiply the amount, the column, with the value column. So these two columns, we're going to be multiplying them together to give us our equations. So let's go ahead, let's hop into example number 1 and look at exactly what these questions look like and how we can solve them. So let's go ahead, let's talk about Sally and Terry. So Sally and Terry blended a coffee mix that sells for $2.50 by mixing together two types of coffee. Now, let's go ahead, let's stop right there. Now, when we're looking at this table, the bottom row, that usually goes the mix or your final solution. So right when I read that, they blended a coffee mix that sells for $2.50 by mixing together two types of coffee. That immediately tells me that I have a coffee mix. Now, what I'm mixing together is they are using 40 milliliters of coffee A that costs $3. So I have coffee A and coffee B, as we'll read in the second little part of the sentence here. How much of coffee B consisting of $1.50 did they mix with the first? So here's what we know. We know that we have 40 milliliters of coffee A. So I'm going to write that here, 40 milliliters. Now, what I don't know is how much of coffee B that I have. So coffee B, that's X. Now, in terms of the values, I know that coffee A, that costs $3. I know that coffee B, that costs $1.50, $1.50 here. And then lastly, I know that the mixture at the end, that costs $2.50, so I'm going to leave that here. Now, with the equation, well, rather, actually, we missed something here, so the amount for the coffee mix. Now, here's what you need to think of, okay? The mixture, or the final solution, that is whatever the amounts for the two blendeds. So, for example, the two things that we are blending together here are A and B. The total amount for the mixture is going to be those two things added together. So it's going to be X plus the 40 milliliters. So that's what we're trying to find here. We're trying to find X. How much of coffee B do I mix together with coffee A to get to this prime dollar position, which is $2.50. So now, remember, to find the equation, we just multiply across here. So it's 40 times 30, so it's going to be 120. And then that's going to be X times 1.50, so it's 1.5X. And then if I multiply across here, we're actually going to distribute. So it's going to be 2.5x plus 100. Sorry, I ran out of room there, but that's 2.5x plus 100. So now, it is always whatever you are mixing together, these need to add together. So it's 120 plus 1.5x. And then that's always equal to whatever you are mixing to find. So it's 2.5x plus 100. So now, if we want to solve here, let's get all of our x's onto one side. So I'm going to subtract the 1.5x's to the other side here. So that gives me 120 equals, that's just 1, so it's 1x plus 100. So now if I subtract by 100, gives me 20. So, in total, I need 20 milliliters of coffee B. When I mix 20 milliliters of coffee B with 40 milliliters of coffee A, that gives me my $2.50 coffee mixture there. So that is how I found the answer for example number 1. So how much of coffee B do I need? I need 20 milliliters, so x equals 20 is my answer there. So now with that, let's go ahead, let's look at an example where we have percentages instead. So Nick and Chloe have 2 grades of milk from their small dairy herd. So immediately I'm going, okay, well, so that means we have milk 1 and milk 2. Now, one of those is 24% butterfat, and another that is 18% butterfat. Excuse me, geez. Now, how much of each should they use to end up with 42 liters of 20% butterfat? So we're making a milk mixture here. Now, the amount that we want the mixture to be is 42 liters. Now, from this, it doesn't matter which one in terms of the amounts. It doesn't matter which one you call x. Call milk 2x, call milk 1x. For me, I called milk 1x. Now, what this tells me is that I have x liters of milk 1. Well, the amount for milk 2, I have to take the x liters that milk 1 is and subtract that from the total. So that's going to give me however many liters of milk 2 that I need. So I'm going to find that at the very end here when I find my answer. But I know that I need x liters of milk 1, and I need 42 minus whatever liters I'm using for milk 1 to make this mixture. Now the values are given. So milk 1 is 24%, so there's 0.24. The milk 2 is 18%, so 0.18. And then lastly, for my mixture here, we want it to be that 20% butterfat. So now for the equations, it's going to be 0.24 times x. And then it's going to be 0.18 times 42 minus x, which that gives me 7.56 minus 0.18x. I went outside the box again. I'm not really good with the handwriting there. And then if we continue on there, that gives me 0.2 times 42. That gives me 8.4. So now if I go ahead and set up my equations, so my equations here, they're going to be, again, remember, whatever you are mixing together, those are adding together. So it's 0.24 plus 7.56 minus 0.18x, and then that's equal to 8.4. So that's how I set up my equation there. So now, oh, I forgot the x on the 0.24. Sorry about that. Now I have my x there. It's kind of, now it looks a little bad, but that's okay. So now, let's go ahead, let's add together our like terms, aka the 0.24 and the negative 0.8x. So that gives me 0.06x plus 7.56, and that's equal to 8.4. So now if we subtract here, so if we subtract the 8.4, or rather not the 8.4, if we subtract the 7.56 over, that gives me 0.06x equals 0.84. Divide by 0.06x. Oh, not 0.06x. Excuse me. Oh my goodness. I don't know what's going on with me right now. Lordy. There we go. X equals 0.6. My calculator over here. It gives me 14. So 14 is the amount of liters up here for milk 1. For milk 2, it's going to be 42 minus 14. So it's going to be 28 liters. So that's how I found my the amount for my mixtures there. So I need 14 liters of milk 1 and 28 liters of milk 2 to make the total of 42 liters of the 20% butterfat that we are looking for there. Okay, so that's how we find the mixture for Nick and Chloe there. So now let's go ahead, let's move on to the back. So we have just 2 more to do. I know that was a lot of work for those 2, but let's just try it 2 more times here, and I will have a homework for you guys walking out of here. So let's go ahead, let's look at numbers 3 and 4 here. Let me just turn in my notes, make sure I'm getting all my numbers right. So with number 3 here, in Tasha's Candy Shop, chocolate, which sells for $4 a kilogram, is mixed with nuts, which are sold for $2.50 a kilogram. Chocolate and nuts are combined to form a chocolate nut candy, which sells for $3.50 a kilogram. How much of each are used to make 30 kilograms of the mixture? So immediately I'm going with names. It's going chocolate, chocolate, then nuts, and then lastly, we're just going to call it the mixture. So that's what I'm going to call my names there, or rather fill in my names there. Now, for the amounts, we want a total of 30 kilograms for our mixture. Now, from that, we want it to be X amount of nuts, and whatever the amount of nuts is, minus the 30 total kilograms, or rather, X of the chocolate mixed with 30 minus however much chocolate we mix to make the 30 total kilograms. So that's how we're going to find our amounts here. We're going to say, hey, we need X amount of chocolate. That's how many kilograms of chocolate we need. And then subtract that from the 30 total that we want our total mixture to be in weight. That will give us the amount of nuts that we need in terms of kilograms. Now, for the dollar amounts, it was $4. And then the nuts were a total of $2.50. That's a weird 2. I'm sorry, I gotta fix that. That's bothering me. It's a 2 there. There we go. A little better. Now small 2. And then lastly, we want the mixture to sell for $3.50. So if we go ahead and multiply this out here, so this gives me 4x. And then it's 2.5 times 30 minus x. That gives me, let's see, 30, that's going to be 75, and then minus 2.5x. Hey, look at that, I kept it in the box this time. And then 30 times 3.5 is going to be 105. So it is 4x plus 75 minus, what do we get, 2.5x. And that equals 105. Okay, so there we go. So now, if we go ahead, add together our like terms there, so it's 1.5x plus 75, and then it equals 105. Subtract over the 75. I get 1.5x equals 30. Divide by 1.5. I get x equals 20. So I need 20 kilograms of the chocolates. Mix that together with 10 kilograms of nuts, and that gives you a total of 30 kilograms for your mixture, which comes out to $3.50 per kilogram. So there is number 3, all done, example number 3. So that's how we use this mixture table again. So let's just one more time. Numero 4. Let's talk about it. So, how many pounds of a 15% aluminum alloy must be added to 500 pounds of a 22% alloy to make a 20% alloy? So, here's what we got. We have some aluminum. We're mixing it together with an already previously made alloy to make a new alloy that we'll call the alloy mixture. Now, with that, we don't know how much of the aluminum alloy that we need, so we're going to call that X. We do know that we have 500 pounds of this already pre-made alloy. Now, together, that gives me X plus 500. So, however many pounds of aluminum, how many pounds of aluminum we need, plus the 500 pounds of the alloy that was already made for us, and that gives me my total amount there. So now for the values, the aluminum is 15%, 0.15. The alloy that was previously made was 22%, so 0.22. And lastly, we want this new alloy mixture to be 20%. So now if we go ahead and multiply here, so it's 0.15x. 0.22 times 500 is 110. And then 0.2, when we distribute that in, I'm going to make it real small so it fits in there. So it's 0.2x plus 100. There we go. Make sure it fits in the box there. But when we go ahead and add the first two, so add the two things that we are mixing together, so 0.15x plus 110, and that equals 0.2x plus 100. I'm going to subtract over my x's to one side. Gives me 110 equals 0.05x plus 100. Subtract the 100 from both sides. Gives me 10 equals 0.05x. Divide by 0.05. And I get x to be 200. So we need 200 pounds of aluminum to mix with this already 500 pounds of alloy that we have to make 700 pounds of this new alloy that's only 20%, or 20% alloy, excuse me. Now, if you guys have any questions, please make sure to email me. I probably will still be in the building, but just not in class today, so just let me know if you guys have any questions for me or if something's wrong with the homework or something other than that. Just make sure to go ahead and reach out to me. Okay, thanks guys.